In a quiet lab at Boston Children's Hospital, a single photograph would go on to shock the world. A small white mouse with what looked like a human ear growing on its back. It wasn't science fiction, it was science, pushing the boundaries of what was once thought impossible. Welcome to Informatics, where science meets the future. If you're fascinated by discoveries that redefine what life itself can be, make sure to subscribe and join our community of curious minds. The year was 1997. Inside Boston Children's Hospital, a team of researchers led by Dr. Charles Vacanti was working on a question that could change medicine forever. Can we grow human-shaped tissue outside the body? Their approach was bold. They created a biodegradable, ear-shaped scaffold made from a special polymer, a structure designed to dissolve over time. Then, they seeded it with cartilage cells and implanted it under the skin of a lab mouse. Weeks later, as the scaffold dissolved, the cells began multiplying, fed by the mouse's own blood vessels, until a new, flexible ear began to form. The world called it the Vacanti Mouse. And for the first time, humanity saw the potential of lab-grown organs. The goal was never to create hybrids or strange creatures. It was a proof of concept. Could living cells be guided to grow into complex, human-like shapes? What Dr. Vacanti's team discovered was groundbreaking. By using biodegradable scaffolds as templates, scientists could train cells to form cartilage, bone, even organ-like structures. This meant that one day, doctors could grow replacement parts made from a patient's own cells, eliminating the need for organ donors and reducing transplant rejection. This was the birth of tissue engineering, the science of growing the body as building blocks outside the body. The Vacanti mouse became an icon of modern science. Part curiosity, part inspiration. It proved something remarkable, that cartilage, a tissue once thought nearly impossible to regenerate, could be engineered and sustained in the lab. That success opened doors to new possibilities: artificial skin for burn victims, lab-grown bladders for reconstructive surgery, and today, even 3D printed mini-organs used for testing drugs and treatments. The mouse that grew a human ear wasn't a monster, it was a milestone, a moment that bridged science, fiction, and reality. Today, scientists are building on that legacy with 3D bioprinters that can create tissue layer by layer. We're growing mini hearts, kidneys, and lungs in labs, not to play God, but to save lives. Imagine a future where your doctor can print you a new organ built from your own cells, perfectly matched, ready to heal you. That future is closer than you think. The Vacanti mouse experiment changed medicine forever. It showed us that our bodies aren't static. They're rebuildable, and that someday soon, we might grow what we once thought we could only replace. This is the future of lab-grown organs. This isn't. If stories like this ignite your curiosity, make sure to subscribe, hit the bell icon, and share this video with someone who loves science as much as you do. Because the future is already growing.